These are the notes for the bottom flap of section number 4 of your Unit 3 Quadratic Functions flipbook. The essential question being answered in this section is, how do the values of h and k change the location of a quadratic graph? In a previous video, we explored how the value of a changes a quadratic graph or changes the parabola. Now we're going to see how h and k change the location of the quadratic graph. Notice it's changing the location. A changed the shape and direction of the parabola. H and k, we will see, change the location of a parabola or the quadratic graph. So let's take a look. As you go through each of these, class, I gave you values for h and k. Go ahead and write the function, and we're writing this in vertex form. So if h is 0 and k is 0, our function would look like x minus 0 squared, quantity squared, plus 0. And we can rewrite that. If we've got zeros here, that's just the same as the function f of x is equal to, think about it, since 0 does nothing, this just ends up being x squared. And since adding 0 does nothing, our function is actually the same as just writing x squared. And you should recognize that that's actually the parent function. That's the parent function. Or the parent, we can write the parent graph. I'm having some problem with the electronics. Hang on a second here. Let's rewrite that. We'll call this the parent function or the parent graph. It's the graph that we use to compare all other parabolas, all other quadratic graphs. When you graphed this one before, you notice that the vertex was 0, 0. At 1, we are at 1, positive 1, and at 2, we are at positive 4. And then we can reflect those points across the axis of symmetry, which is at the y-axis. We connect those together. And there is our parent function or our parent graph. We're going to use that one again to compare what happens to all the other graphs as the values of h and k change. So let's do the next one. What if h were 2 and k was 0? H is 2 and k is 0. Let's rewrite our functions. You can write this down. F of x is equal to x minus 2 quantity squared plus 0. There's our h value. Remember, class, when you put h into this equation, the vertex form, the sign flips because the minus sign is part of the equation. If you remember what this equation looks like, let's go ahead and write it down here so we have it as a reference. I'll just put it right here. F of x is equal to a times x minus h squared plus k. All of our a values for the first 5 graphs will be 1, so we won't even have to write it. But since the minus sign is part of the equation, if h is 2, it shows up in the equation as x minus 2. And then the k is 0, we keep the sign of that as just positive. So if we take a look at this, here's what happens is, we know that h is 2 and k is 0. Well, that means our vertex, we know our vertex is at h comma k. So that means we know our vertex is at 2 comma 0. So now our vertex has moved. Instead of being at 0, 0, which it was here, h and 0 are both, h and k are both 0. Now our vertex is at 2 comma 0. We have shifted the vertex to the right. Our other points, because a is 1, our shape is going to be exactly the same as the shape we had on the previous graph or on our parent graph. It looks identical. The next point here, we just go 1 over and 1 up, and then we go over 2 from the vertex and up 4. So we're plotting points at 3, 1 and 4, 4. And we're plotting a point at 1, 1 and 0, 4. Let's go ahead and connect those together. You can see, class, that the direction of the parabola is exactly the same. The shape or the width of the parabola is exactly the same. all h did was shift the vertex over, and I'm going to make an arrow here to show you. It actually pushed the parabola over 2 units. Let's take a look at the next one. What if h is -2 and k is equal to 0? Well, now we know, again, h and k define our vertex. That means for this particular function, our vertex is going to be at, again, it's at hk, which is at -2, 0. Take a look at our vertex. Now it's shifted over to -2, 0. It just got pushed to the left. It got pushed to the left. So the vertex is at -2, 0, so it got shifted to the left. Because the a value didn't change, it's still 1, our shape and our direction of our parabola are exactly the same. I'm going to draw these from the vertex class. Just go over 1, up 1, and then from the vertex you go over 2, up 4. Then reflect those points on the other side of the vertex. So we can show the direction of this parabola is still up because a is +1, it's positive. The shape of the parabola, the shape of the parabola or the width of the parabola looks to be the same as the parent graph because a didn't change. But because h changed, this parabola actually shifted 2 units to the left. Let's take a look at what happens when k changes. So now we have a sample where h is 0 and k is equal to 2. Alright, well, we know again our vertex for this particular, oh, by the way, you could rewrite this equation excuse me. By the way, you can rewrite this equation, and I forgot, on these two equations here, I could have written this as f of x is equal to x minus 2 quantity squared. The 0 doesn't do anything, so I could have just dropped it off. And the same with the third graph. I could have just dropped it off and not even showed it, because when k is 0, it doesn't do anything. Over here, we could just rewrite this equation as f of x is equal to x squared plus 2. Because the 0, the h value of 0, doesn't change the value inside of the parentheses. Alright, let's take a look. We know that our vertex is going to be at hk, which in this case is going to be at 0, 2. So now look what happened. Instead of our vertex moving left and right, 0, 2 is right here. Our vertex actually shifted up. Since our a value is still 1, our shape of our parabola and the direction of our parabola will be exactly the same. It doesn't change. But the vertex, because k is now positive 2, it shifted our vertex up 2 units. I'll go ahead and graph our parent graph. Over 1, up 1. Here's another way to think of it. You can go over 1, up 1, over 1, up 3. That will get you the proper points for the parent graph. Over 1, up 1. Over 1, up 3. And again, if you look at it, a is still positive 1. That means the parabola still opens up, and the shape of the parabola didn't get compressed or stretched because a is equal to 1. So now we have, I'll draw an arrow here, we have an upward shift. As k went up from 0 to 2, we shifted up 2 units. So we probably can predict, class, that if k goes down, or negative, it's probably going to shift down. And that's exactly what happens. Let's go ahead and write this function. You can write this the same way as we did before. Since h is 0, we could just drop that out of the equation. This is just x squared minus 2. We know the vertex of our original function is going to be at h, k, which we know in this particular instance is 0, negative 2, and that means our vertex is going to be at 0, negative 2. Our graph just shifted down. We can now draw our parent graph again because the a value is still 1. It didn't change from before. An a value of 1 means your shape of your parabola and the direction of your parabola stay the same as the parent graph. So we're going to go over 1, up 1, over 1, up 3, and then opposite direction, over 1, up 1, over 1, up 3. We'll go ahead and connect those points together. And I missed both points. Let's try it again. There is our parent, basically the shape and direction of our parent graph. The only difference is a k value. Man, I'm having a hard time drawing. I'm just going to live with that. You guys know what it's supposed to look like. The shape and direction of our parent graph, but now the graph has shifted down on the y-axis because our k value went negative from 0 to -2. So now you can see what h and k do on a vertex form quadratic. The h value is going to move the graph left and right, and the k value is going to move the graph up and down. Notice, class, h and k do not change the shape of the parabola. It's the same width in every case, and they do not change the direction of the parabola. Only the a value can change the width or the shape of the graph and change the direction of the graph. Remember, negative a, it's going to face down or open down. Positive a, it's going to open up. Let's do a practice one, and let's put a, h, and k together. Here is function f of x is equal to -2 times x plus 1 squared plus 3. Let's pick a couple things out. The first thing we notice is a equals -2. Here is our a value. Let's find our h value. Here's our k value. A is -2. That means the graph is going to be opening down because a is negative, and it's going to be thin because as a gets to be bigger and bigger negative numbers, -3, -4, -5, the graph will get thinner. Now we know that h and k are in our equation, so let's find out what h is. Actually, h and k define our vertex. So if our vertex is going to be at h comma k, remember when you pull the h value out of the equation, the sign flips. So here it shows you that the h value is going to be -1, even though it shows positive in the equation. Our k value is 3. That means our vertex is going to be at -1, +3. Let's graph that. -1, +3. There's our vertex. And I'm not going to go through plotting the other points for the parabola. We know, class, that 1, it's going to be pointing down, and number 2, it's going to be thinner than the parent graph. So if you just want to approximate what that's going to look like, starting from the vertex, just kind of draw the parabola so it looks narrower. Sometimes I'll ask you just for an estimate of the graph. Take a look at that. You can see it looks stretched or pulled farther down from the parent graph so that the two sides start to look like they are closer together. So this is what will happen when we have a -2 for a. It's going to be upside down or opening down, thinner than the parent graph, and the vertex is going to move from 0, 0 to -1, -3. That means it moved over to the left 1 unit, and the vertex moved up 3 units. And then we go ahead and sketch the parabola.